Hello everybody, my name is Shivansh Srivastava and I am going to be your teacher for today. We are going to talk about some grade 12th physics and I have decided to take up the topic of electric dipoles. So this is a subtopic that is included in your chapter of electrostatics. Electrostatics is basically what I call chapter 1 and 2 of your NCRT. I treat it as one chapter because the concepts are very similar and very interrelatable. Okay, so we are going to talk about electric dipole for today, and also electric dipole being one of the most important topics. Why? Because a lot of questions come from this subtopic. And that is not just the only reason why it is important. It's also important because we are going to study magnetic dipoles in the future. And the formulas of electric dipole and magnetic dipole are very similar. If you have a good command on electric dipoles, then you can obviously get a very good, equally good command on magnetic dipoles without doing much effort. So this is like killing two birds with one stone. Something like that. Okay, hitting two targets with one bullet. So let's talk about electric dipoles. So guys, this lecture is going to be of NEET level. Okay, for the students of NEET, whoever is preparing for NEET, this lecture is going to be helpful for all the students like that. Okay, now we will first begin with the definition and the illustration of what electric dipole is. So imagine that there are two points, and on those 2 points there are two charges. One is a plus q charge, okay, and one is a negative q charge. So you can notice certain things, that these two charges are opposite in nature. One is positive, one is negative, and these two charges are also having the same magnitude. Okay, so this is the first observation that you should make. And also these 2 points are kept at a fixed distance like this. Okay, these 2 points are kept at a fixed distance. Let's call this distance as d. Alright, so this is what an electric dipole is. Now in reality, electric dipoles are mostly found in chemical substances, like for example the hydrogen chloride molecule like HCl. Little bit of chemistry over here. I believe that you know this bit, that chlorine is more electronegative than hydrogen. So in that case, what happens is that chlorine takes a little bit of charge towards itself and it becomes a delta minus, like slightly negative charge, and hydrogen becomes delta plus. So you can see that these two are equal and opposite charges separated by a fixed distance, which is the bond length. So in real life, whenever we see dipoles, what we will generally notice is that these charges will be small. Okay, these are small charges, and this distance is also small in nature. Okay, so guys, this is what a dipole is. Now that we know dipole, we will define a quantity which is called the dipole moment. Dipole moment. So every dipole has a dipole moment. So this is not a dipole moment, by the way. This is a dipole moment. So a dipole is not a measurable physical quantity, but a dipole moment is a measurable physical quantity. I hope you guys know the difference between physical quantities and those things that are not physical quantities. Okay, this dipole is actually a physical object. You can think of it like this. And dipole moment is a physical quantity related to the dipole. Now, how do we define this dipole moment? So guys, first of all, you need to understand that the dipole moment formula is usually represented by the symbol P. Okay, just give me a second, guys. I will just rub this off because this is taking unnecessary space. You already understand this. So yeah, now this P is the symbol, most commonly used symbol for dipole moment, and this is defined as magnitude of one of the charges, because the magnitude is same anyway. Necessarily it has to be positive, because guys, the magnitude is never negative. I hope all my students know this, that magnitude is never negative. We have studied this in our basics. And guys, this P is defined as Q multiplied by this distance, which is D. Okay, so how will we remember this? That the dipole moment is defined as the magnitude of one of the charges multiplied by the distance between them. But however, guys, this formula is not yet complete because this dipole moment, this quantity is actually a vector quantity. Okay, it's actually a vector quantity. Now you will say that, sir, charge and distance, these two seemingly are scalar quantities. So it should have a direction, right? So where is the direction? You have just written magnitudes. So guys, don't worry. Let me show you what the direction is going to be. So the direction, and you can actually note this down, you can remember this, is actually very important. Please do not forget this. Especially in physics, we always take the direction of the dipole from negative to positive. Okay, so always remember that the direction is from negative to positive. Okay, P vector is equals to Q into D into, let's say, I will add a P cap over here. What is this P cap? P cap is a unit vector which is from negative to positive. Now some students, they tend to get confused over here because their knowledge with unit vectors is a little bit dicey, but don't worry about it. Let me just tell you that whenever you multiply a unit vector with a certain magnitude, what you get is the complete vector. You know, it's kind of like saying that what is 2 kg? 2 kg is 2 times of 1 kg. What is 2 meter? Or 3 meter or 5 meter. 5 meter is 5 times of 1 meter. So we take the magnitude and we multiply it by the unit. And that is how we get the physical quantity. Similarly, to get the vector quantity, we take the magnitude and we multiply it with the unit vector. And that is how we get the vector quantity. So guys, how do you define the dipole moment? P is equals to QD into P cap. Now, let's talk about one more common confusion over here. Now, in certain books, you will find that the dipole moment is actually explained as Q into 2A. Now, I have got this a lot of times from my students, and I hope that you don't have this doubt. In certain books, P is given as Q into 2A, and in the book, it is clearly mentioned that this is 2A. Okay. My dear children, please never be confused between D and 2A. The distance between the two charges is what you have to take. It does not matter if you write it as 2A or if you write it as D. It does not matter. It is the distance between the two charges that has to be taken. Okay, I could have represented this D or 2A or I don't know, X or some other letter of English language. It does not matter. What matters is which physical quantity you are taking, and that is D. Alright guys, so I hope that this part is clear to you. Dipole moment is clear. Dipole moment is a vector quantity and it is represented by QD into P cap. P cap is the direction of unit vector from negative charge to the positive charge. I hope this is clear. Second thing is the unit. Okay, so the unit of dipole moment, I am representing it with a P vector. So you can guess the unit. So how do we guess the units? Guys, these are very basic things which you must be aware in physics. Whenever you see a formula, you can guess the units. Okay, you don't have to remember the units. You don't have to be like, oh my god, what the units are, and start cramming and start panicking if you can't remember. No, nothing like that. You can always guess the units by looking at the formula. There is charge. What is the unit of charge? Coulomb. There is distance. What is the unit of distance? Meter. So what is the unit of dipole moment? It is Coulomb meter. So simple. Okay. So please never be confused with this thing once again. Okay. Alright guys, so this is how we define the dipole. Okay. So I want your attention. Okay, you can take a look at this once again, and in the meantime I will talk. So I want your attention on this one fact, that the dipole moment is actually a vector quantity. Okay, so I'm going to use this fact and intrigue you with a problem. You all know about the molecule of carbon dioxide, right? So carbon dioxide has this structure. I hope you know this. Okay, if you don't know this, please talk to the chemistry teacher, but I'm pretty sure you know this. So, carbon dioxide, right? Now, you know that oxygen is more electronegative than carbon. Yeah. So, we can say that this oxygen has a delta minus charge on it. Similarly, this also has a delta minus charge on it. Now, you see, guys, this carbon is going to have a delta plus charge because of this, and also another delta plus charge because of this. So in short, you can say that this charge on carbon is actually 2 times of delta plus. Alright, so instead of writing this as simply delta plus and delta plus, we should actually put an addition of these two. And in my opinion, rather than this, just simply write it as 2 delta plus. Okay, so from this analog, from this example, if I tell you that there is a 2q charge over here, okay, what is this? This is a 2q charge, alright. There is a minus q charge over here and there is a minus q charge over here, alright. So these are charges like this, and this distance between them is d, and this distance between them is also d. What is the total dipole moment? So guys, in this case, the answer will be, wait, I'm not going to tell you yet. Let me explain. Think about the answer, but let me first explain. So, first of all, we will understand that this 2q can actually be written as q and q. Now, if you notice carefully, this is one dipole, which is like this, because it is from negative to positive, alright, and the magnitude is q times d, correct? Similarly, this is another dipole and it's pointing like this. Why? Because negative is here, positive is here. So this is also qd. What we have simply done is that we have understood this 2q charge as a combination of q and q charge. Alright guys. So what we have done is that we have divided it into two parts and then made two separate dipoles. Okay. Now the addition of these two dipoles is 0, because whenever you add equal and opposite vectors, this equates to 0. That is why the total dipole moment of carbon dioxide molecule is going to be 0. So guys, whenever in chemistry you hear that, oh, this molecule is polar, okay, or this molecule is non-polar. I'm pretty sure in organic chemistry you must have heard this polar protic solvents, polar aprotic solvents. Such kind of terms will come in organic chemistry and sometimes inorganic chemistry also. You will notice over there that this word polar is used. So what makes a molecule polar? Guys, a molecule is polar when the dipole moment of that molecule is not 0. In the case of carbon dioxide, we know that there are two dipoles, one over here, and that is why carbon dioxide is considered to be a non-polar molecule. However, if we talk about the water molecule, so this is oxygen, this is hydrogen, and this is hydrogen. In this case, you will notice that there are actually two dipoles. Okay, let me just draw it with a different color. So there is one dipole like this and another dipole like this. Alright, and there is some angle between these two. I do not really need to know what this angle is. You should be knowing what this angle is because your chemistry should be better than mine. So there is some angle between these two, and this angle is definitely not 180 degrees. We know for sure, because if it was 180 degrees, then again two equal and opposite dipoles, water would be a non-polar molecule. But water is actually a polar molecule because these two dipoles will add up and give you a resultant like this. And because it has a net dipole moment, so we can say that water is a polar molecule. Alright, so I hope this part was clear. So I want you guys to do one quick question. So what is that one quick question? Let me just give you over here. I will just quickly write that one quick question. So this is minus 2q charge, okay, and there is a q charge over here, all right, and there is a q charge, let's say, over here. So in this case, what you will notice is that this minus 2q can be written down as minus q and minus q, all right. So it can be written as like this. So you have one dipole like this and one dipole like this. So this is also q into d, because I am saying that the distance between these two dipoles is d, and the distance between these two dipoles is also d, which might not always be true. So this is d because I have taken it to be d. Now you might actually ask a doubt over here that, sir, will it always be d? Maybe, maybe not. It should be given in the question. If it is not given in the question, then you have to assume that the distances are equal. And guys, what if the angle between these two is 60 degrees? If the angle between two vectors is 60 degrees, then I am pretty sure that you know that if there are two vectors of the same magnitude, these are both QD in magnitude and the angle between them is 60 degrees. So what will be the resultant? So my dear children, the resultant will be somewhat like this, and you should know what happens when two equal vectors are added at 60 degrees. The resultant is root 3 times of the magnitude of either one of them. And that is your answer. Root 3 QD is your correct answer.